All right, so we've made it through our algebraic proofs and we're going to start doing our first geometric proofs. And just like when we started geometry, we started with segments. We are going to start with proving things about segments. So the first thing we need to do is talk about a couple of properties of congruence. These are going to sound very similar to properties of equality, except that instead of an equal sign, we're going to use a congruent symbol. So our first property is the reflexive property of congruence. And you remember for equality, that meant that A equals A. Well, the reflexive property of congruence pertaining to segments is going to say that segment AB is congruent to segment AB. And you might not think that's a big deal, but let me show you a quick little example of what that might look like in a problem or in a proof. So let's say we have a triangle like this, and then we have another triangle drawn like this. And so both of these will be right triangles. And if this segment that they both share is segment AB, this is C, and this is D, well then it's important to know in some of the proofs that we're going to do that these two triangles have a congruent side. And the reason it's congruent is because of the reflexive property of congruence. AB is congruent to AB. The next one we're going to do is symmetric. And you remember symmetric said that symmetric property of equality said that if A equals B, then B equals A. So this is going to be very similar. We're going to say if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay, so we're not going to really draw a picture of that. What we're just going to say is when we have AB congruent to CD, that can be written CD is congruent to AB. And that's going to be important when we're doing proofs. A lot of times we need to change the order of things, and this helps us do that very easily. Our transitive property of congruence, remember transitive property of equality said if A equals B and B equals C, then A equals C. Well, this is going to be the same thing. So if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB, our original segment, is also congruent to segment EF. And so that, remember, that says if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. And that's helpful to us because if all that's true, then segment AB can be rewritten as segment EF. So that may come in very handy when we're doing a proof. So real quickly, take a look at these couple of statements and tell which property justifies each statement. So this one says angle QRS is congruent to angle QRS. Hopefully you see that's the same thing, which is kind of like a reflection. It's the exact same thing back, so that reminds us that it's our reflexive property. And remember, it's the reflexive property of congruence. And here we have angle, measure of angle 1 equals measure of angle 2, so measure of angle 2 equals a measure of angle 1. Well, that's the symmetric property of congruence. So remember, symmetric is kind of like if you folded it in half along this line right in the middle, folded in half. This 2 would land on this 2 and this 1 would land on this 1, so it's got symmetry, kind of like a graph. The last one, AB is congruent to CD and CD is congruent to EF, so AB is congruent to EF. Anytime you see that kind of thing going on, that's our transitive property of congruence. All right, so let's look at a little example and let's go ahead and do a short little geometric proof about this segment we see over here. It says example 2, we're given that M is between N and O. So we look over at our picture and we see M is between N and O. And we're supposed to prove that X equals 5. Well, this is great. They already told us the answer, right? But the hard part is all of the steps have to get justified. So for everybody that doesn't like to show their work, this is going to be a change for you because not showing your work is not an option here. So we start out our simple 2-column proof. It says M is between N and O. Well, that's right here. That was our given information. So that's our first reason. Remember, given is always the first reason. Then the very next thing we see, M is between N and O. And we see NM plus MO equals NO. And we look up here and we see NM plus MO equals NO. And you're probably thinking to yourself, we've done this before. I've seen this exact drawing before. And if you can remember when you've seen me draw this, that'll be pretty good because that means you remembered a lot. The reason that NM plus MO is equal to NO is something that you have learned and you're supposed to be memorizing called the segment addition postulate. So you're going to have to go back into your chapter 1 notes and make sure you know all of those postulates and all of those definitions. So now that we know that, they say that 2x plus 3x minus 9 equals 4x minus 4. Well, it looks to me like they took this and wrote it here, took this and wrote it here, and took this and wrote it here. Why can you do that though? It's not just enough to say, well, that's how you do it. Why is that how you do it? That's something that we've learned, and it's called substitution, property of equality. So now after that, we see we have a 2x and we have a 3x. Well, I know that that makes a 5x minus 9 equals 4x minus 4. Well, again, I just did something. I combined the 2x and the 3x. How was I able to do that? What property did I use? I used something that I've known for a while now called combine like terms. And now I look at my problem and I'm just going to solve it like I do all my problems. So I'm going to put all the x's on the same side. So now I get x minus 9 equals negative 4. So to move that 4x, I subtracted something from both sides of the equal sign. So I subtracted same thing from both sides of an equal sign, which is done using the subtraction property of equality. And the last step is I'm going to add 9 to both sides. So I'm going to finish up with x equals 5. Still my answer, so I put a box around it. And by adding 9 to both sides, I was using the addition property of equality. So if we flip over to the back, we're going to see several pictures that we're familiar with, but we're going to learn a little bit more about how to use these in proofs. So the first one we see is the segment addition postulate, which says that that piece plus that piece equals the whole thing. And anytime you see that B is between A and C, what you see in this picture, you can always say that AB plus BC equals AC. And your reason is the segment addition postulate. Okay, move down to this picture. You know this picture, this is a midpoint. It says that this piece and this piece are the exact same length and they're congruent. So when you see that M is the midpoint of AB, you know right away AM, that's the distance from A to M, is equal to the distance from M to B. And the reason you know that is that you know the definition of midpoint. Also, if you have a picture of a segment and you see this statement that says AM is equal to MB, well, that means you know that M is the midpoint of segment AB. And the reason you know that is also the definition of midpoint. So definitions work both ways. Sometimes they tell you something's a midpoint, so you use what you know about the definition. And sometimes you see what you know about the definition and you can use it to say that something's happening or something's there because you know that definition. Okay, here we have two congruent segments, and it tells us that segment AB is congruent to segment CD. Well, if two things are congruent, that means they're the same length. So segment AB is congruent to CD tells us that the length of AB equals the length of CD. And the reason we know that is we know the definition of congruent. Okay, flip over to the next page and we see the same picture again, but this time they tell us the length of AB equals the length of CD. Well, if we're told that, because we know the definition of congruent, we know that when two things are the same length, that means that they are congruent. And I know it seems nitpicky, but there is a difference between congruent and equal. And so these two things are congruent because of the definition of congruent. Remember, congruent tells us that things have equal measure. So if we're given things with equal measure, it's safe to say they're congruent because the definition of congruent. All right, so leave this alone. You can go ahead and attempt these if you want to. We're going to work them in class. If you want to attempt them now, go ahead, give them a try, and then we'll look at them in class and see how we did.